Hello, good day, scholar. I welcome you back to today's class. So, very quickly today, we are going to be looking at the concept of vector. Now, you remember in our physics class, we group physical quantity into two major groups. The first group, we say the scalar, right? While the second group are the vectors. Now, from the definition of scalar quantities, we usually say scalar quantities are those physical quantities that has only magnitude, right? But the vector comes with an extra piece of information, which is what? The direction. And that is why when we want to define the vector, we usually say vector quantity are those physical quantity that has both magnitude and direction. An example include the displacement and force. And when we say it has both magnitude and direction, we mean that a body is moving from a known location, say point A, to a specific location, point B. Now, let's quickly talk about the direction, the magnitude, and the resultant of a vector. This figure on the screen denotes a vector, while the length of the line denotes the magnitude. The arrow denotes the direction. Now, let's quickly talk about an equivalence vectors. You see, two vectors are said to be what? Equal if and only if they have the same magnitude and they have the same direction. Now, observe these two lines of vector, the vector AB and vector CD. They have the same magnitude. You can say vector AB is equals to vector CD. Let me tell you about the negative vectors. We can say a vector is negative of the other if they possess an equal magnitude but act in opposite direction. As we can see here, the vector AB has the same length with vector CD, but their arrow is moving in opposite direction. So therefore, we can say vector AB is equal to the negative of vector CD. Now, let's see what vectors looks like on 2D plane. Let's assume we have a Cartesian plane, x-axis and y-axis. Moving from a point A, 1, 1, to point B, 4, 5. Here we can see that there is a movement or there is a change in position in both x-axis and y-axis. Now we have to determine the amount of change in y-axis and the amount of change in x-axis. We can get this by using the change formula. For y-axis, we have y2 minus y1, where our y2 is 5 and our y1 is 1. So 5 minus 1 is equals to 4. Also for x-axis, using the change formula, we can say x2 minus x1 equals to 4 minus 1, which is equals to 3. Now, we can find the magnitude of the distance from A to B using the distance formula, where absolute value of r is the magnitude of the distance from A to B. We can say absolute value of r is equal to the square root of x squared plus y squared, where x is our change in x and y is our change in y. And if you are conversant with Pythagorean triple, you will know that this will form a 3, 4, 5 triangle, which means that the magnitude of r is equals to 5. Can we now talk about the resultant vector? Now, this resultant vector is called net force in physics. and some mathematics textbook will say it is vector addition. Now, what is resultant vector? A resultant vector is that single vector which is equivalent to two or more vectors. We have two geometrical methods for finding the resultant vector when two vectors are added together. And we need to know that these two methods are mathematically equivalent, but the difference is just in the way we actually present them. Let's see the first one, the triangular law. You see, if two vectors are represented by two sides of a triangle, taken in the same order, note that the order is very important here. We can say nose to tail or head to tail. Now, their resultant is represented by the third line, which is the closing side of the triangle. Now, let's see the second method, which is the parallelogram law of vector addition. You will observe that the placement of the two vectors in triangular law of vector addition was from head to tail. But here, the placement of the two vectors are from tail to tail, which means that the two vectors are represented by the adjacent side of a parallelogram, and their resultant is represented by the diagonal of the parallelogram passing through that point. Now, let's assume we have angle theta between vector A and B. Mathematically, the angle facing our resultant will be 180 minus theta. And when we have something like this, we can actually use our cosine rule, which means that for us to get the magnitude of our resultant, it will become r squared equal to a squared plus b squared minus 2ab equals 180 minus theta. Now, let's give these variables some values. Let's assume a equals to 10, b equals to 20, and our theta is equals to 60 degrees. This means that we have our r squared to be equals to 10 squared plus 20 squared minus 2 times 10 times 20 equals 120. Then 10 squared equals to 100. 20 squared equals to 400 minus 2 times 10 times 20, that's 400. And cos 120 is minus 0.5. When we evaluate, it means we'll be having r squared equals 500 plus 200. And when we add 500 plus 200 together, we'll be having r squared equals to 700. And when we take the square root of both sides, we'll be having r, the absolute value of r equals the square root of 700. And the square root of 700 is 10 root 7. So with this, we have been able to find the magnitude of the resultant of that two vector. Okay, so last but not the least, let's see vectors on 3D space. You see, the best way to figure this is by looking at the corner of your wall. Now, looking at the corner of your wall, you will see three orthogonal lines. And let's say we have one to the z-axis, another one to x and y axis. Each line forms 90 degrees to the other two, which means that they are all 90 degrees. Let's assume we have a unit vector k to the z-axis, a unit vector I to the x-axis, and a unit vector j to the y-axis. We can represent the position of a vector using the column representation or the row representation. For our column representation, the position of our vector x will be 1, 0, 0. Since our vector x is parallel to the x-axis. Same thing with the position for the vector y. The position for the vector y will be 0, 1, 0 because the vector y is also parallel to what? Y-axis. Also for the vector z, the position will be 0, 0, 1 because the vector z is parallel towards z axis. The value is the same for the row representation, but the presentation is different. We have come to the end of this section. If you have any question, you can put it down in the comment section box. And please like this video, share, and subscribe to our channel. Thank you very much. Till we meet again. Bye.